Hey, madam. So here's a theorem. It's a term called theorem, right? So the question says, prove the theorem which states that C angle AF equals to A angle BC. So let's look at where C angle AF is. So we have to prove that C angle AF from C down to A, here's the angle that we want to prove, to F equals to A angle BC. So from A, we are going to angle B, and then we're going to C. To prove this theorem, what you need to do first, you know the steps by now, right? We have to do the construction step. Okay. You don't have to write the word construction, but it's advisable to write it so that you remember what you're doing. Right. So what you're going to do, under construction, you are going to draw a diameter. We're going to start from A, it goes through zero or through center, and then it goes to another part. Like we're going to draw that diameter. So because it's a diameter, it ends somewhere. It must then end at a particular point. Name it whatever letter you like. So now I'm going to name it P. You can name it M, you can name it whatever that's not given here. I'm also, from this point, we are also going to draw a chord, another chord which is not here, from P going to C, because we want to prove B. We are going to go opposite of that. If we wanted to prove C, we will go opposite of C. So meaning that we'll draw a chord that goes to B. Okay? Now we're going to go to C. Got it? So this is the first way of proving this theorem. You only need a diameter and a chord. What we would have created here, you can go to C and say this is going to be C1 and C2. If you look at your angle A, you've divided it into three angles. So you can call this A1, A2, and A3. Okay. Now, under construction, what am I writing? You draw a diameter. Diameter. What's the name of the diameter? AP. Diameter AP. And what else did I draw? Another chord. And chord
C.
PC. Now, what else did you indicate that was never there? So you can say angle C1, C2, A1, A2, and A3 are shown. Remember this, the reason why you're writing this is because you never created, I mean, these angles were never there anyway. So you're going to use them to prove your theorem. Okay. This is your construction step. We are done. Now we go to the next step. We are now going to prove the theorem. Let's remember what we are required to prove. What you are required to prove, which is RTP, is the statement here. CAF equals to ABC. Right. Now we are proving the statement. Step number one, you must remember when you've drawn a diameter, you have created angles in a semicircle, right? So maybe start there if you want to. What I would say is that start with that angle, or if you like, you can see you have angles in the same segment. If you look at angle P and angle B, they are angles in the same segment. So start with that and say angle P equals to angle B. Reason, angles in the same segment. which is an updated segment. This is the reason that you should be using. Okay. Number two, we are now going to indicate that C1 plus C2 is 90 degrees. So angle C1 plus angle C2 equals to 90 degrees. Why are we saying that? That is, those are angles in a semicircle. Right. But, okay, we are fine with that, right? But how can I write P1 using C1? Then you write angle P, not P1, sorry, angle P. Angle P equals to angle C minus angle A2, because this is the angle we were referring to. Those are some of angles of a triangle. Or if you wanted to write it differently, you can say P plus C plus this whole C here plus A2 must equal to 180, and then you reverse the calculation. But to save time in your exam, you don't have that time. So what you're then going to write is that angle P, this is 90 degrees already, right? So you say P equals to 90 degrees minus A2.
So can I ask a question?
Yes.
P and A2 are not the same angles, right?
P and?
B. Like, I should,
No, P and B, we say that they are the same.
you know what I'm saying? P and A2.
No, they are not.
Okay.
Yeah. If you look at where A2 is a very small angle. Yeah. So what you write here, you say P equals to C1 plus C2 minus angle A2. The reason being that these are some of the angles of a triangle. Okay. Well, you can tell that P is going to be 90 degrees minus A2. But what do you remember about P? Remember from our main statement where we started, we said P equals to B. P is not what we are trying to prove. B is what we are trying to prove. So then we have to write this B, this P as B. So we can then say, therefore, angle B equals to 90 minus A2. Do you see why I say start with that statement? Yeah. Now we come down here. What do you remember about a radius and a tangent? A radius or a diameter is perpendicular to the tangent at all times. Then we're going to write that. Then we can say A1 plus A2, because you can see those are the only angles between your radius and the tangent, right? So here's our radius. I don't know why it's there. So here's our radius, and here's our tangent. Okay, they make 90 degrees. So then we say angle A1 plus angle A2 equals to 90 degrees. Why? Radius perpendicular to tan. Okay. Then what do you see here? I've got, and now I need to find A1. Remember, A1 is this angle here that we wanted. So we are then going to say A1 equals to 90 degrees minus A2. What else equals to 90 minus A2?
It is B.
It's B. So then we can say, therefore, A1 equals to angle B, which equals to 90 minus A2. Okay. All right. Now we are happy. That's all that we needed. What is A1? If you remember, A1 is CAF, right? From our main question. So in conclusion, so I'll write there, conclusion. You don't have to write conclusion. I'm writing it for you to remember what we've done. In conclusion, that statement is true. C angle AF equals to A angle BC. And this is how you prove this theorem. Okay.
Okay.
If for some odd reason you don't know how to prove it using this method, right? There's a second method. So that's why I'll do both. The second method is the one that you wanted to use. So let's go to them. I prefer the first one because it's easier to remember. With your second method, you are going to use the angle at the center is twice angle at the circumference. So that's the logic behind it. Okay. But let's do it together. Under construction, what do we draw? We are now going to draw radii. We draw what? Radii from A to O and from O to C. So we're going to draw radii AO and CO. Well, if you're going to use A1, A2, A3, you have to indicate. So I'll say A1, A2 here. I only need A1 and A2. And maybe here I'll use C1 and C2. So you can see what I did was the twos are inside the triangle and the ones are out. Okay, so just follow that trend. So if you're going to put the two inside, make sure that everywhere your twos inside the triangle are inside. Make sense? Okay. So angles that are shown, A1, A2, C1, and C2 are shown. Well, it's not as it's you're not going to get marks on this. You are just indicating that you are showing those angles because you are going to use them instead of naming the angles. You're going to use the ones and the twos and whatever. Does that make sense? All right. So we are done with our construction. Where are we going? We are now going to prove. So under proof, where do we start? Remember, the main thing is to know that when you approach this theorem using this method, you're going to use angle at the center is twice angle at the circumference. So we want to show that this angle equal to that angle. But if you look at this angle here, it's going to be angle at the center. And that one is angle at the circumference. Again, if you look at this angle, it's an angle inside a triangle. Can you see that? So it's it's the third angle in this triangle AOC, right? Now, let's start some. What I would tell you here in this case is that you can then start with angle A1 or A2 equals to C2. Let's start there. Okay. Angle A2 equals to angle C2. Why are we saying that? If you look at AO, it's a radius. CO is also a radius. So this and this are equal, right? So we say angles between radii. All right. Then our key part is to use the angle down here. Don't go up there. So now we are going to say if A1 and C2 are equal, these three angles, when we add them, what do we get? 180, correct? So we're going to say angle A1 plus angle C2 plus this angle here. What's the name of that angle? It's AOC. So A angle O, A angle O, C, okay, equals to 180 degrees. That is sum of angles of a triangle. Okay? Then remember we said A2 and C2 are equal. We want to use A2. So we are going to make C2 to also be A2. So it's A2 plus A2. We get 2A2 equals to what? Equals to 180 degrees plus AOC equals to 180. Okay? But what we know about AOC, remember AOC, now I take A2 to the other side. So AOC is going to be 180 degrees minus 2A2. Right? Right, we leave it there. We must also remember that AOC is angle at the center, and that angle V is angle at the circumference. So now we write AOC, we can write but here if you want to, but AOC equals to 2 times angle B, which is that angle there, the one that we want to prove, right? Why is that? Angle at the center equals to 2 times angle at the circumference. All right? Then from here, we substitute 2b. Remember, we were not in the intention of proving AOC. We are in the intention of proving B. So now we are going to substitute this 2b in place of AOC. So we can write 2b equals to 180 degrees minus 2a. You understand why I'm doing this, right? We then divide everything by 2, then therefore angle B equals to 180 divided by 2 is 90. 2a divided by 2, you get A2. Right. Okay, now we know what angle B is. So this angle is 90 minus A2. Here's that radius thing. Now we have A1 plus A2 gives us 90 degrees. Can you see that? Here's our radius. Here's our tangent. So that last statement in the other proving is also applicable here. So now we're going to say angle A1 plus angle A2 equals to 90 degrees. Radius is perpendicular to the tangent. What is A1 again? Now we move A2 to the other side. A1 equals to 90 minus A2. Right, which is what we wanted, right? We mentioned that B is 90 minus A2.
So now because A1 and this part of B are equal, we can say
Yeah, now we conclude by saying that therefore angle B equals to angle A1, which they both equal to 90 minus A2. Then we write the statement. What do they say? Therefore, that is true, because remember, B is this angle here. It's ABC, right? And then A is CAF. So then we can say, therefore, CAF. Sorry, I'm putting angle on C. We have to put an angle on A. C angle AF. What does it look like? I'm high now. C angle AF equals to A angle BC. And then we have done the conclusion. Does it make sense? Are you sure? Okay, cool. That's how you prove tan chord theorem.